First off, let's talk about what is a function. Functions denoted by this f of x. We're going to input something here for x, and it's going to give us some kind of output. So as I start plugging in numbers for x, it's going to churn out numbers over here. So functions, think of it like a machine. As you put in some raw materials, you're going to get something on the outside, some output. So as I plug in maybe -2, I could get -2 out, plug in 6, pi. Our standard definition is for each value of x, I'm going to only get one y. It's going to be a 1 to 1. Now notice this one out here is not a function. I'm getting 1 to 1 here, but what happens when I plug in 1 into my function? Well, I get two values, a 15 and a -0. Can't have that as a function. One input should only have one output. This is not a function. So how can you tell something's a function by just looking at the graph? Well, we're going to use what's called the vertical line test to demonstrate. And I'm going to use my little lanyard here to help me out. Now how this works, the vertical line test, is I need to go from left to right, and I should only be touching my graph once. So as I go across here, what happens? I see that I'm actually touching it twice. We just saw that you can only have one value of y for each value of x. And in this case, in this circle, I have several cases where I have two values of y. So this circle is not a function. Now what about this graph? As I go from left to right, I see I am only touching my lanyard once, so it is a function. Now even though this one is separated, we'll see in a minute this is called a piecewise function, as long as I have one value for y for each value of x. And as I go across here, it does look like I have 1 and 1, but as you see here, when x is 0, I have two values of y. This is not a function. Now if one of these was circled or hollow, meant it doesn't equal, and this one does, then it would be a function, because that would be my x, this would not be my x. But since these are both solid, that means these both are values, so this would not be a function. So again, the vertical line test will help you see whether or not something's a function. You should only be touching that line once. All right, now let's look at domain and range. What domain and range are is a way for me to try to box in my graph. Figure out what are my containments here? What are my restrictions? As I see here, arrows, so those are going to go towards infinity. With the domain, I'm looking at all the x values. So I need to look at my x-axis here, from -infinity to +infinity. When you're writing the domain, you need to always start at -infinity. So as I go here, do I have a graph here? Well, technically I do, because it's going to continue on and eventually hit or trend towards -infinity. So where does my graph start? It starts at -infinity. And where does my graph stop? Well, let's see. Keeps on going, and I see it is, because of this arrow, going towards infinity, +infinity. So it's never going to stop. So as you write your domain or range, you're going to write it in interval notation. This will be your start of the graph, and this will be your stop. And since we're using interval notation, we've got to use those parentheses or brackets. I know I'm never going to reach these, never going to equal infinity, so I'm going to use parentheses. So here's the domain of this graph, looking at the x values, all the way from -infinity to +infinity. Now the range, let me look at the range. Again, the range will be the set of all y values, and I want to go from -infinity to +infinity. So now I'm looking here at the y-axis, and we're going to start at -infinity. Where does my graph start? Bam, starts right there. Starts at the value of 2. So my graph starts at 2. And where is it going? Where does it stop? Well, I'll see here my graph isn't going to ever stop, so it's going to go all the way to +infinity. Again, parentheses with infinity, and I figure out, does my graph actually have a value of 2? And it does. So I'm going to use brackets here to represent my range. So my range is going from 2 to infinity. Domain from -infinity to +infinity. So again, like I said, you're trying to box in your graph. Where is it contained? And this is how you would write it in interval notation, which is what we're going to do in this class. Your start value is going to be first, your stop value is going to be second.